Hello, good afternoon. Now I would like to introduce about myself. This is Venkatesh. Now I am going to give presentation regarding to the first unit of data structure. In this unit we are going to discuss about three things. In demonstration regarding to the asymptotic notation. As already I have given a statement, here we are going to discuss about three topics. Under that, first one is asymptotic notation we have completed now. Then we can go for next one is arrays. By arrays, what do you mean by an array? So actually by using variables we have the drawback. What is the drawback is by variables we can store only one value at a time. If you want we can store more than one values by using more number of variables. If the program having more variable declarations, it will take more amount of time. To overcome that drawback, we need to go for another feature, another nice feature which is supported in C language, which is called as arrays. Array can be defined as collection of elements which are belongs to similar data type. And all these array elements must be stored in continuous memory. What do you mean by continuous memory? If the first element is stored in 1000 address, second element must be stored in 1000 to next 1000 for, if it is for example it is the integer data type. So finally array is nothing but it is a variable where we can store more than one values at a time, and these elements must be stored in continuous memory. That is the introduction regarding to arrays. Next thing we are going to discuss about that. See, in the data structure subject, as a faculty of data structure subject, we are going to give the demonstration in one standard notation. That is, every data structure we are going to discuss with four common points. One is the definition, and another one is representation of definition of data structure, representation of data structure, and operations of data structure, applications of data structure. So here data structure is nothing but data structure can be defined as collection of organized data. Collection of organized data is nothing but when we can say the data is called as organized data. If the data is represented in one standard notation, that may be sequential or may be hierarchical manner or maybe tabular representation, that is nothing but hierarchical, that is nothing but standard notation or standard representation. Then if the data is represented in sequential manner or hierarchical manner or a tabular representation or graphical representation, then we can say the data is called as a standard structure or organized data. Collection of that type of organized data is nothing but data structure. Next thing, data structure can be classified into two types. One is linear data structure and another one is non-linear data structure. Now our topic arrays comes under linear data structure. In linear data structure we have several data structures. One is arrays, linked list, stack, queue. In non-linear data structure we have several data structure, trees, graphs, sets, tables. So these comes under non-linear data structure. First we are going to discuss about array. Already I have given a definition for an array. Then the next thing, representations of an array. Already I have given array elements are stored in continuous memory. Here the first location is used for storing first element, second location is used for storing second element. So here continuous memory means if the first element address is 1000, second one 1002 already have given. So this is nothing but memory representation. For example, if we have five means here maximum we need to store 5 elements. That is integer data type 5 into 2, 10 bytes of memory is allocated at the time of compiling our program. And this memory is called as a static memory. Later we'll discuss what do you mean by static memory, what is the drawback by using this static memory. Then we can go for next thing. Already I have given, so far I have given definition for an arrays. Next one I have given representations of an arrays. Then now we are going to discuss about operations that can be performed on arrays. So we can perform operations is nothing but several functionalities that can be performed on particular data structure. What are the different type of functionalities that can be performed on data structure, that is arrays? One of the operation is the traversal operation. What do you mean by traversal? The process of visiting each and every element in array is called as a traversing. Then go for searching. What do you mean by searching? The process of identifying a particular element is available in the list or not is called as searching. Then go for insertion operation. The process of inserting or adding a new element into the array is called as insertion. But here you have to remember when the insertion is possible. If we have some empty location in an array, then only the insertion is possible. Inserting a new element at the last position, that is very simple, simply by writing a single statement, that is a new element, that is last position is equal to new element. By writing like that we have done insertion. But insertion at the last position is not at all difficult, that is very simple by writing a simple statement. But here we have some complication if you want to insert a new element at any position except the last position. So what we need to do is, here we need to perform the shifting mechanism. By using shifting mechanism we need to shift the elements to end position. Why? Because we need to make the empty location a location at which we want to insert the new element. So that is the story regarding to insertion, and deletion is nothing but the process of deleting an element from the array. See, at the time of insertion, maybe if the array having only the 4 elements, by performing insertion the array is having 5 elements. Regarding to the deletion, if the array having 5 elements, by performing deletion operation it is having only the 4 elements. Then we can go for next operation, that is sorting. See, what do you mean by sorting? In the name only we have the explanation. The process of arranging the elements, array elements in logical order. Logical order means that may be ascending order or maybe descending order. I hope all of you are very familiar with that ascending order and descending order. Ascending order is nothing but we can move from small to bigger. Descending order means we can move from bigger to smaller. See, as a sorting of array elements, this operation is applicable. This operation is implemented in our real life. Regarding to the telephone directory, there the names are sorted. The customer names are sorted according to their names. So that is one of the real-time application where we can use the sorting mechanism. Then next go for the merging. What do you mean by merging is nothing but the process of combining two arrays into a single array is called as merging or not. Suppose consider this array. In this array I want to search B element. So we need to perform searching operation is also in a sequential manner. Start with either first position or start with the last position. So first we need to, suppose I want to search B element. First we need to compare our searching element with A. Why? Because it is the first element. A is equal to B. Here it is not satisfied, not matching. Then we need to go for second matching of second element. B is equal to B. Our searching element is B and then the second element is B. Both are matching. Because of that reason, both are matching. Here searching is successfully done. Why? Because our searching element is found. So the searching element is B is available at first position. That is the searching operation. And traverse operation is nothing but visiting each and every operation, visiting each and every element in the array. First we need to visit A. Visiting is nothing but simply we can display that elements. Simply display A, first to display A, then display B, then display C, then display D, then display E, then display F. So this is traversing of an array. So far I have discussed several operations, which are performed on arrays. There the first one is searching completed, traversing completed, insertion completed, deletion completed. And the next remaining operation, that is sorting. Sorting is nothing but the process of arranging the elements in logical order, either ascending order or descending order. So here we need to compare the first element. Here we need to compare the first element with the second element. If the second regarding to ascending order, suppose if you want to arrange the elements in ascending order, so what we need to do is, first we need to compare the second element with the first element. If the second element is smaller than to the first element, we need to interchange the two elements. If the second element is greater than to the first element, we need to keep same as it is. Then we need to compare the third element with the second element. Third element with the second element. If it is less than to the second element, interchange the two. If it is greater than, keep it as same. So we need to repeat this comparison mechanism until we can compare with the last two elements. By comparing last two elements, we can say that the array elements are sorted. If the elements are sorted, we can say that there the sorting operation is performed on arrays. So every time here we need to compare. In sorting here, we need to compare the adjacent elements. Adjacent element, first element, second element with the first element, third element with the second element, fourth element with third element, fifth element with the fourth element, and so on. So this is the demonstration regarding to sorting operation and arrays. Next we can go for, that is the same. See here the PPT. In first array, it is one real-time example I have taken today explain about the sorting mechanism. Here I have taken around 10 peoples or 10 persons. Among these 10 persons, some of are very small, some of are very larger than first one or larger than third one, maybe like that. Here the peoples are arranged in an order. An order is nothing but not in a logical order, not in a ascending order or not in a descending order. Then what is by applying sorting operation on these 10 peoples, what is the result we got? We got the result like that. Now you can see here the peoples are arranged in, the peoples are placed, the peoples are stand in logical order, that is ascending order. That is first one is very smaller than second one, then second one is smaller, second person is smaller than to third person, third person is smaller than to fourth person, fourth person is smaller than to fifth person, fifth person is smaller than to sixth person. So this is nothing but a sorting mechanism. Then here we have several sorting techniques are there, but for example purpose I have displayed only the selection sorting. In this selection sorting, what we can do is we can select the first smallest element. For example, here we in our hand we have an array with 5 elements. Among these 5 elements, now first we need to select the first smallest element, replace the first element with the first smallest selected element. Then we need to select the second smallest element, replace the second smallest element with the second element. Then we need to select the third smallest element, replace the third smallest element with the third element. Then we need to select the fourth smallest element, repeat so and so mechanism, repeat this mechanism and in n minus 1 steps. Here again we have a new term, that is n. N is nothing but number of elements in the array. See, if array having 6 elements, array having 6 elements, then we need to perform selection sorting in 5 steps. That is nothing but selection sorting. Next we can go for, this is already have given a mechanism. In total selection sorting, how many number of comparisons are required? N into n minus 1 by 2. And here already I have given in starting topic, that is asymptotic notation, that is used for representing the time complexity of an algorithm to decide that which algorithm is best algorithm. So here the selection sort time complexity is big O of n square. And next bubble sort is there, selection sort is there, insertion sort is there, merge sort is there, heap sort is there, shell sort is there, radix sort is there. Like that several sorting techniques are there that we will discuss in future units, no problem regarding to that. You can remember only here what is sorting. Arranging the elements of an array in order, either logical order, either ascending order or descending order. Next, already as given several sorting techniques are there. Next one is insertion sort. In insertion sort, what we can do here is, see, first element we can keep as same as it is. Then we need to think about the second element, where we need to insert the second element. We can insert the second element either before the first element or after the first element. When we can insert the second element before the first element, if the second element is, I am talking about only the ascending order, that is smaller to bigger. If the second element is smaller than to the first element, we need to insert the second element before the first element. Then we need to think about the third element. We can insert the third element either before the first two elements or after the first two elements or in between the first and second elements. So we need to do the comparisons. First we need to compare with the first element, then we need to compare with the second element. So total 2 comparisons are required to insert the third element. If it is greater than to the first element and greater than to the second element, then we need to insert after the first 2 elements. If it is only greater than to the first element and less than to the second element, we can insert in between the first and second elements. If it is greater than to all the 2 elements, then we need to insert after the 2 elements. I hope you understand the algorithm regarding to insertion sort. So next we need to think about where we need to insert the fourth element. See, you can guess fourth element is inserted in different locations. Either the first one is either before the first 3 elements, after the first 3 elements, in between the first and second, in between the second and third. When before the first 3 elements. If it is smaller than to first 3 elements, when we can insert the fourth element after the first 3 elements. If it is greater than to all the 3 elements, when we can insert fourth element in between first and second, greater than to first, less than to second. When we can insert in between second and third, greater than to second, less than to third. Then we need to insert in between second and third. So this is the entire demonstration regarding to insertion sort algorithm. Here you can see already have given, here also we have the different 10 peoples are there. How we are going to insert is, first we need to pick up the second person. If second person is greater than, second person is larger than first person, we can keep that same as it is. Then we can pick up the third person. Then we need to compare the third person with the first person. If the third person is larger than to the first person, then we need to compare the third person with the second person. If third person is larger than to the second person, then we need to place third person after the first 2 persons. Then we need to think about where we need to place the fourth person. To place the fourth person, first we need to compare the fourth person with the first person. If fourth person is larger than to the first person, we need to compare fourth person with the second person. If fourth person is larger than to the second person, we need to compare fourth person with the third person. If fourth person is larger than to the third person, then we can understand that we need to place, we need to insert, we need to arrange the fourth person after the first three persons. We need to repeat the same demonstration, same mechanism, and for arranging all the elements in given array. Then regarding same procedure we need to repeat for fifth person, sixth person, seventh person, eighth person, and so on. So this is the demonstration or algorithm regarding to insertion sort. See, next, go for next one. Yeah, so already as I mentioned, that is selection sort and insertion sort. Selection sort and insertion sort. Insertion sort we have compared, we are thinking about the second element and the third element, that is the algorithm regarding to insertion sort. So like this we have several sorting techniques, but it is not the correct time to discuss about all the sorting techniques. In future class, in future we'll have separate unit for this. Okay, leave over that. This is the entire story regarding to sorting operation on arrays. I hope you understand several operations we can perform on arrays, and I have discussed some operations, that is searching operation, deletion operation, insertion operation, traverse operation, sorting operation. All these are the different type of operations that can be performed on arrays. Then next, so here already I have given, that is here we have taken in array half of the elements are already sorted. Then we need to think about second half of the element. That second half of the elements are also arranged in sorting manner, arranged in sorting or arranged in logical order by using the same insertion sort algorithm. And next we can go for, so this is entire demonstration regarding to arrays. Next